Okay, question 6. The fourth term of a geometric series is 2. Okay, and the seventh term is 54. Okay, so you just substitute now n in here, yeah? So ar to the 4 minus 1 equals 2. Ar to the 7 minus 1, then we put 7 in there, is 54. So this would be ar cubed is 2. So we call that equation 1. Ar to the power 6 is 54. Equation 2. So we want to find the common ratio. So remember, the best thing to do here now when you're solving is to divide, okay? So take the highest power, ar to the power 6, divide by ar cubed, equals to then 54 divided by 2, okay? So the a's will cancel, and then take away the powers using indices, so you get 6 take away 3 is 3, and that's 27. And to get r, then we're going to cube root. So r turns out to be 3. So that's part 1 answered. We've got the common ratio there. Part 2 then is to find the sum of the first 10 terms of the series, giving your answer correct to 1 decimal place. So of course then, once you've got r, you need to work out a, don't you? Okay. So if we sub that into equation 1, is it? So we've got a times 3 cubed equals 2. So 3 cubed is 27, so a will be 2 over 27. Okay, so that's what a is there. Not very nice, but that's what it is. And then they want the sum of the first 10 terms. So remember then, we're going to use this formula for sum. Okay, just 10 terms. So S10 will be a, which is that. Okay, keep it as a fraction because it's not a very nice decimal there. 1 take away 3 is r to the power 10, all divided by then 1 minus 3. Okay, so on your calculator, just make sure you do all this in one go. Okay, so press the fraction button, and you need to press the fraction button again. So 2 then, down arrow, 27, cross arrow, bracket, 1 minus 3, power button, power 10, close bracket, arrow down, 1 minus 3, answer is that, press SD. So 2186, what do they want it to 1 decimal place? 2186.96, so that will be 2187, won't it? 0.0 to 1 decimal place. Okay, so then in part 3 it says find the least value of n for the nth term to exceed 125,000. Okay, so we don't know what n is, okay, but we want the value of n such that the nth term exceeds 125,000. Okay, well, remember now, nth term is ar to the n minus 1. And we know a to be 2 over 27. We know r to be 3. So we have that. So what I'd be tempted to do then is that fraction there, take it over and divide. So you've got 3n minus 1 is greater than. Okay, and we want it to be greater than 125,000, don't we? Because it says at least 125,000. So you're going to divide by that fraction. So 3 to the power n minus 1 is greater than, let's work that out. So I get 1,687,500, 1,687,500. Now the question is then, how do I work out this power? Okay, how do I solve that there? Well, we can use logarithms, if you remember. Okay, logarithms will work here. So a couple of ways of doing logarithms. Okay, you could take logarithm of both sides. Okay, so basically you end up having log 3n minus 1 is greater than log 1,687,500. Okay, so you take logs of both sides, and remember then with logarithm you can bring the power down. Okay, so the power here is n minus 1, so bring it down in front. So you have n minus 1 log 3 is greater than log 1687500. Okay. We could then, instead of multiplying with the bracket, you could think of the bracket times log 3. So let's take the log 3 over and divide. So we're left with n minus 1 on this side, and then log 1687500 divide by log 3. Okay? And then that minus 1 take over the other side. So it becomes log 1687500 divide by log 3 plus 1. So you get your calculator. Now, because I've just used log, this is standard log to the base 10. And on this old calculator I've got, it's got a log button on there to the base 10. Okay, the newer calculators, you've got to press shift, I think, or something to get the log to the base 10 up. So press fraction, log 1687500, close bracket, go down, log then 3, close bracket. Let's go back there, close bracket, let's go across plus 1 then, and I get out n has got to be greater than 14.05, right? So remember, number of terms n has got to be a whole number. So if it's got to be greater than 14.05, n then has got to be 15 terms, okay? So that's the amount of terms you need to get that greater than 125,000.